Hi, this is Dr. A.B.M. Kaish from the Department of Civil Engineering UKM. I'm presenting the paper on entitled Trends in Utilization on High Volume Fly Ash in Engineered Cementitious Composites, authored by myself, Fatin Najwa and Mohammad Nizam Sakimon. Starting with the introduction, engineered cementitious composite is a special class of new generation high performance cementitious composite. It's a cement-based composites introduced in late 1990s by Victor Lee from University of Michigan. So engineered cementitious composite is highly durable due to strain hardening ductility and dispersed tensile microcracking behavior. We can see the stress strain behavior, tensile stress strain behavior of engineered cementitious composites reported by Wyman and Lee in 2003. Let's discuss on the effect of high volume fly ash on the mechanical properties of ECC. So let's start with effect on compressive strength. In general, fly ash increases the strength of cementitious system at a lower replacement level. However, some researchers reported a decrease in strength when high volume cement is replaced by fly ash in ECC. Zaitao et al. In 2010 reported that 50% strength reduction they achieved, they observed for the ECC at 28 days while using 80% fly ash. Masi and Raghul also reported that strength of ECC with 60% fly ash almost same. It showed almost same strength as ECC without fly ash. Effect on flexural strength. Ammasi and Raghul reported that flexural strength of ECC with high volume fly ash is lower than that of ECC without fly ash at 28 days. However, they observed high strength for 40% and 60% replacement with fly ash at 90 days. This behavior might be due to the pozzolanic reaction of fly ash at later ages. Yu et al. In this year 2020 reported that addition of nanosilica into the high volume fly ash mixture improved the flexural strength of fiber reinforced mortar. Effect on tensile strength. Young and Lee in 2007 reported that high volume fly ash causes a reduction in degree of hydration in the interfacial transition zone of fiber mortar matrix, and due to this weak bond, reduction of tensile strength was observed in several studies. Ammasi and Raghul also observed lower splitting tensile strength of ECC when fly ash was utilized at 80% to 100%. This is the graph of splitting tensile strength of ECC reported by Ammasi and Raghul. We can easily see that at 40% and 60% replacement, the tensile strength is almost same as ECC without fly ash. However, at 80% and 100% replacement level, the splitting tensile strength of ECC is much more lower than the ECC without fly ash. Let's start with effect of high volume fly ash on durability properties. So starting with effect on water absorption. Fly ash generally decreases the water absorption of cementitious system. Ammasi and Raghul reported that high volume fly ash contributes to reduce the water absorption capacity of ECC. Capillary water absorption capacity, which is also known as softivity, increases with the pre-cracking of ECC, reported by Samaran and Lee. However, high volume fly ash always helps to reduce the absorption capacity. Later, they also reported that incorporating water repellent admixture in ECC shows lower absorption capacity than the ECC without admixture. This is a graph reported by Ammasi and Raghul in 2018. The graph shows the water absorption capacity of ECC. We can see that water absorption capacity at 40% replacement level is much more lower than higher replacement level. However, we can easily see that water absorption capacity reduced with the incorporation of fly ash, high volume fly ash. Okay, then resistance to frost attack. Shahmaran and Lee in 2007 reported that ECC with high volume fly ash shows acceptable frost resistance according to ASTM C672. The scaling residue on ECC surface was observed within acceptable limits even after 50 cycles of fizzing and thawing. And this is the picture showing the surface scaling of ECC after 50 fizzing and thawing cycles. Then resistance against chloride penetration. Shahmaran and Lee again in 2009 reported that ECC with high volume fly ash shows more than 2% tensile strain capacity after salt ponding and rapid chloride permeability test. It was also reported that sodium chloride solution effectively heals the microcracks in ECC specimens through leaching of calcium hydroxide. This is also reported by Lee et al. In 2007. So this picture shows the crack healing in ECC after exposed to chloride environment reported by Shahmaran and Lee. So we can see in the left hand side the picture before salt pondering. We can see the micro cracks. You can easily see the micro cracks, which is less than 1 millimeter. However, after salt pondering, we can see the micro cracks is almost filled up by white deposit, and this white deposit is nothing but due to the efflorescence, which is leaching of calcium hydroxide from the system, from the cementitious system. Calcium hydroxide is the cement hydration product which is always there after the cement hydration or reaction. Okay. Then resistance against alkali silica reaction. Shahmaran and Lee in 2008 reported zero expansion of ECC bar at the end of 30 days soaking in alkaline environment. ECC is categorized as low risk against alkali silica reaction. After soaking in high alkaline environment, they also found the deposition of calcium hydroxide and alkali salts in the crack path that effectively heals the crack. So we can also say that alkali it is good against alkali silica reaction when we use high volume fly ash. Coming to the end, as conclusion, high volume fly ash effectively enhances the durability performances of ECC in different chemical environments like chloride environments, alkaline environments, then against fizzing and thawing, and also water absorption. So it was reported no adverse effect on the tensile strain hardening behavior of ECC while high volume fly ash was incorporated. However, none of the study reported the optimum percentage of cement replacement level to incorporate high volume fly ash. And also a study on structural application of ECC incorporating high volume fly ash was not reported so far. Therefore, in future, researchers need to focus on especially these two, especially the first one, optimizing the percentage of cement replacement to incorporate high volume fly ash. That high volume fly ash means above 50% of fly ash. And also, while incorporating the high volume optimum level of fly ash to incorporate in structural application. That's all for today. Thank you very much. If you have any question, you can ask. Later I will try to answer. Thank you very much.